Okay, in this introduction on polynomials, we're going to go over a couple of things, and this is just an introduction, so I think probably it's best to talk about definitions first. We're going to talk about what are polynomials, but what are the types of polynomials, terms, which are the individual parts that make up a polynomial. We're going to talk about the degrees of a polynomial, and we're going to talk about, finally, the different parts of a polynomial, okay? And we'll just do it in that order. So first of all, what is a polynomial? Well, let's just look at the word polynomial, okay? And you can probably see two different parts in there. You see the word poly, and if you know what poly means, it means many, okay? And then you see the word nom or nomial. Now, in French, the word nom is another word for name, but in this particular instance, it's just another word for terms, okay? So a polynomial is an algebraic expression that has many terms, okay? So that actually kind of opens up a whole new host of questions, doesn't it? So let's just write that in there. An algebraic expression with many terms. Okay. Now, I'm going to assume you know what an algebraic expression is. It's just a combination of, numbers and variables and that sorts of thing, just numeric symbols. But the word terms, and that's our second part here, is something that we should probably talk about. Now, what is a term? A term is just a collection of numbers and variables. So it's a collection of numbers and variables. Or I should say variables, because you can have terms that are just numbers or just variables, okay? So an example, what would one look like? Like 3x would be a term, or just y by itself would be a term, or the number, 2 would just be a term. So, or you can even have, more complex terms. You could have something like 3x, y squared, z. It's all one term. Now, why is it one term? A term is put together with multiplication, okay? In other words, what separates the different symbols, the 3, the x, the y, the z, is the multiplication operation, all right? Which kind of leads us to another part of what this definition is all about, all right? So let's say I have something like this. Let's say I have, again, let's just go with 3x plus 2y. Okay, now that is also a polynomial. This is many terms. Now you'll notice that this is made up of two different terms. It's made up of the 3x and it's made up of the 2y. And you'll notice what separates them. It's an addition. Okay? So let's go back to the definition about polynomials. Algebraic expression with many terms that are separated by additions and or subtractions. Okay? So again, algebraic expressions that can have many terms, but the terms themselves are separated by additions and subtractions. Okay? But in an individual term, it's just all multiplications. So let's go back to this example we had over here. You see 3x plus 2y. So this is a term, the 3x, and here's your addition, it's separator, and then here's the 2y, another separator. So what you have here is a particular type of polynomial, you have something called a binomial. Okay, again, bi meaning 2. All right. So 3x by itself would be an example of a monomial. The word mono meaning 1. Okay, let's go to 3x plus 2y plus 4. That would be a trinomial. Again, the word tri meaning 3 rather. And here's a trinomial. And finally, after that, you have something, let's put another term in there. So let's do something like 3x plus 2y plus z plus 4. We're going to call this a 4-term polynomial. You might be tempted to call it like a quadrinomial or something like that. You really don't need to. Anything after 3, they just start using numbers. So you'd say 4-term polynomial, 5-term polynomial, 6-term polynomial, etc. There are some really archaic words that they use, like a quatric, I think, but quatric polynomial. But that's something you really don't need to have to know. So just remember, after 3 terms, again, separated by additions and or subtractions. I should have put a subtraction in there just to give you an example. Okay? You just start calling them 4-term, 5-term, 6-term, that sort of thing. Okay, so now we've just talked about the types of polynomials, right? Monomials, binomials, trinomials, and then, numbered polynomials after that. Terms, we said, are just a collection of numbers and or variables. Okay? Now let's talk a little bit about what the word degree means. Okay, this is a little tricky. Let's just do this real quickly. Degree. A number like 2 has a degree of 0. It's not the same as an exponent, it's just a degree. All right, so like, for example, a number like 2 or 3 or 10 or 1,000, whatever, it just has a degree of 0. A variable like x, let's just say x to the first, has a degree of 1. And in this case, it's exactly like the exponent, right? So, for example, something like x squared has a degree of 2, and so on and so forth. So, I want you to think of degrees as basically the same thing as exponents, except with numbers. All right? Now, with exponents, the exponent on a number like 2 is 1, right? So that would be the exponent, but it's not the degree. The degree would be 0. And that's just by convention. That just means that that's what we've agreed to. And I'll tell you why in a later video. I don't think it'd be really important to go through that right now, right? But right now, that's how you would classify these. So just look at the particular exponent on the variables only, and that will tell you what the degree is. Okay? Now, let's talk a little bit about the different parts of a polynomial. And this is the very, very last part of this video. Okay? Parts of a polynomial. I think probably the best one to use is like a trinomial as an example. Okay, so let's just do something like 3x squared plus 2x plus 1. Okay? Now, what have you noticing in here? I've got 3 different terms, right, separated by an addition or a subtraction. If something has a degree of 2, that is called a quadratic term. Okay? Now, it's called a quadratic term because you see that 2 there? If I were to graph this, you're going to get something called a parabola. Okay? And parabolas, you'll notice, crosses the x-axis. Remember, this is called the x-axis. This is the y-axis. It crosses the x-axis a possibility of 2 times. And that's what the degree basically tells you, how many times maximum your graph will cross the x-axis. So using that same logic, this term, the middle term, where the exponent is 1, is called a linear term. And what would you think that would mean? So if you just had like 2x plus 1 or just 2x, you would form not a parabola, but you would form just a straight line. And notice that the line only crosses the x-axis once. So again, it tells you how many times possible, the maximum, it could cross the x-axis. And then finally, the number here at the end, and it has to be a number, it can't be a variable, is called the constant. And we said that has a degree of 0, right? And that basically are the different parts of a polynomial. Oh, one last little thing that I probably should talk about too, besides these. The number in front of a variable is always called a coefficient. Okay? And that's pretty much all you need to know about the different parts of a polynomial. I hope that was helpful.